So now here you can see it also generate the one layer. Okay, this type of map we can get in here as wind. So for that I simply click on here, and now I want to set the uh, stress 98%. So here you can get that. You can see I simply add the plated. Suppose here is the low speed. I want to show this type of color. Suppose this type of color I want to show for the low speed. Get at the line to show this type of green color. But I want to show this type of yellow color. And where I find out the high speed, I want to show this type of red color for wind speed mapping. And further, I try to apply these things. So now it will be set also import these things in here. So click on the import. So here you can see now we can get that wind speed map. Okay. So here you can see this type of region. We find out that high speed of wind as a red color. Okay, and this type of region we find out the low speed of wind. And also you can see about your binary map. Mainly it's your chlorophyll map. So we can get this type of things here. You can see. So now these two map we get. One is the wind map. One another is the LG map. So now we try to find out the what is the correlation between that wind speed and LG volume concentration. So let's go. Let's check about there is a positive or negative correlation. We try to find out from here. And in this time, if you want, you can also use here the big region. There is no problem because in this time we are not making the time series chart, so that's why it's not a problem for that. Okay, and you just remember that you have used the same time period. Okay, for these
Yes,
two
yes.
data set for the correlation. Okay, I also put it the same time period also for that LG volume year of 2000 to 2020. So click to the run. In this time, we generated the two map, wind and LG. So now we try to find out what is the problem about that. It show that size not work. So for that problem, it's not loaded. When it we across the limit, it's not loaded for the LG volume. So we try to put here the 2010, was 2010, and then check this map will be loaded or not. It loaded. So this is our F. Okay, it's work now. Yeah, it's work. We can get the 2010 to 2020, 10 years. So I simply adjust the color. It's stressing 98%. With the LG. So now I apply. Some networking issue. Time to put it. Okay, so now it's okay. You can see. And I try to import these things. Or further set this color. So just simply copy the variable name and paste after the object name of this. Just paste it here again. Okay, so now you can get the two images. One is that wind, another is that algae bloom. Okay, this type of images you can find out from here. So now in this time we try to make the correlation. What is the correlation between the two things? For that I just use the previous same code. Try to develop these things for the correlation, wind and chlorophyll concentration, water body. So for that, what can we do? For that correlation, okay, just like copy from here. I use the same code, just change the data, mainly wind and LG, and try to check what happened. And correlation, just paste in here. So in this time, we try to find out these two things. So here you can see. So in this time, we call the image one image. Suppose one image for that chlorophyll image and another for that wind. So we just simply intersection between that chlorophyll and wind. So just simply call this variable name. Suppose I call the variable name one image for that chlorophyll. Chlorophyll mainly it's binary sum. I simply copy it's the chlorophyll and I simply paste here this chlorophyll first imagery. Another is the wind imagery, wind mainly your wind map. So we already make the wind map here. You can see the wind. So simply I copy the wind and this wind I simply paste in my correlation coordinate. So it also okay. Then random points in this time it will be our boundary shapefile, mainly TS boundary. So just I simply copy the variable name about the TS boundary. Where is it? Yeah, TS boundary. Okay. So these are study area. So just I paste in my correlation code TS boundary. Okay. So further we are just simply display and also okay we have to use the combo. Basically we just call the binary sum. We copy paste here binary sum. From the binary sum we just take the FAI band and also call the wind. So basically wind, we copy and paste here, wind. And from the wind, we just take about that mainly our band. This is U component of wind 10 meter. Just like copy and paste here. Okay, so first of all, try to run the code, then I change the rename it. Okay, so try to check the result first. Okay, so okay, it show the if I did not match any bands available band the LG. Okay, we have to use the LG. Try to put at the LG band in our in here. So now click run again. So now let's check what happened. Working. Okay, this is the point about that. Take the random points from here. Calculate correlation. It generated the correlation chart in here. Okay, great. We can get this type of things here. You can see. So it's about the positive correlation. Okay. So mainly we find out that wind and chlorophyll concentration. It show the positive correlation. It means that when wind is increased, mainly wind flow is increased, this type of region Lg concentration also increased. Okay, we find out that you can see it indicating the positive correlation. Okay. So in
Mm.
this time, we also rename this type of things also made better. Basically, it's the temperature and chlorophyll, it show that, but it will be changed. So basically, in this time, our first it will be chlorophyll, and it show about that wind. Okay, so it's a chlorophyll, and it will show about the wind speed. When wind speed is high, suppose wind speed is the high, then also chlorophyll is also high. Okay, so we try to add in here.
Can the formula appear on the graph if possible?
This one.
Can the formula for the correlation appear on the graph, like maybe the formula, the R square, can it appear on the graph with a value? Is it possible?
Okay, R square value. Yeah, yeah, yeah. It was also supposed R square equal to what? Okay, it also show about that. Basically, R value, the correlation value. It
Yeah.
also possible. Yeah, yeah. Check, check it from correlation. R square value. What is the R square value? We can get from here. So now we try to find out that R square value. So it's called the correlation coefficient. So for doing these things, find out the correlation coefficient. We have to find out that coefficient value, R square value. So let me try just calculating the R square value. Okay, so let's go. So in this time, for that correlation, we can use here the different types of correlation, such as Pearson correlation, as well as we can also use the other correlation. So in this time, suppose Pearson. Okay, so for that Pearson correlation, we are just calculate the correlation value from here also, and coefficient we can also calculate from here. So let's go try to do it for the Pearson. So for that, I just take a variable. Suppose I put the variable name is that Pearson R, Pearson R, and then equal to, I simply call my image. So image mainly, which image you want to use in here for the correlation. Then this time we try to use at the two images. Okay, we simply call the combo mainly where I join. So this chlorophyll and this temperature I join in here. Just I simply put in here. So it's my combo. It's contain the two things. One is that chlorophyll, another is that wind. So just I put here the reduce region, and further put all of those argument one by one. So just make a curly bracket start, and also curly bracket in here. Okay. And now reducer in this time to calculate the Pearson R correlation. Mainly R value I have to calculate from here. So just I put here this reducer. I put here the reducer is that P dot reducer dot Pearson Pearson's uh, correlation. So this is the function, and geometry mainly it's your boundary. So just I put here this boundary name. What is the boundary name? It's TS boundary. Okay, so I simply copy the name from here. That is it. So TS boundary I simply copy and further paste here. So scale mainly I put here that 1000 meter, and further it's not remove that, it's not it, remove that, and then try to print that value. We can print this Pearson R value. Copy and try to check what happened. It now calculate that. Now I'll try to check. There you can say get the R value is that this type of value you can get here. So basically it's R value 0.6. So it's indicating the positive correlation. Okay. 0.6 we can get that. It means that it's the positive correlation. And when you can get the negative value, it means that it's the negative correlation. And when I find the correlation is the 0, it means that there is no correlation between the two variable. Okay, so this is the code for that identify for the Pearson correlation between the two variable. One is that chlorophyll, another is that mainly for algae or wind speed. Okay, so now we try to find out this for the big scale. All right, like suppose I just simply take a new and then try to check the result for the big area. Then check what happened. Suppose okay, suppose I draw this study area look like that. Suppose it's my study area. I consider the whole lake and then check the correlation. Then we also get the more better result. It's my study area. Reason I want to find out the correlation between that LG and also correlation between that wind speed. So mainly where the wind speed is the high flow of wind, then we can find out that high concentration of that LG. So I simply draw. So this is my study area. So now click the run. In this time we can get the result for the whole lake which I draw in here about that. So now try to check about this result. So now I can get this type of map here. You can see, and it also show about that correlation result you can get from here. So here you can see we can get this type of map, wind speed, and also get for that LG. So now it's working. Yeah, wait some time. So now it's working. Check what happened. Okay, we can get it. You can see. Okay, we can get the positive correlation between the two things, and also computing the R square value. So I think it's some network issue, so that's why it takes some time. Okay, so here you can see we can get this. We can get 0.4. Okay, positive correlation. It means that it is the positive correlation because positive we can get in here. So it means that where the concentration of algae is high, where the wind speed is also high. Okay, so it's the positive correlation you can find out from here. So basically, this is the process about that when you want to find out the correlation between the two variable. So in this time, when you want to work for the temperature or other unit, just you have to change in here. So in this time, you just make a new layer about that temperature or about that any other variable. Okay, you can consider in this here, and then make a map about that. Look like that wind map. You just make the temperature map or any other or precipitation map, and then find further you are just try to find out the correlation between the two variable. Okay, and it also show about that r square value we can easily get from here. Okay, so you also try. I will send you this code. You try to for other parameter find out the correlation between that. Okay.
So you
Okay.
said for the temperature, what we're gonna do? We're gonna change.
Yeah, you have to just change the wind. So in this time it show about the wind. For the temperature you have simply change it. Okay, just simply import your image collection for the temperature, and then simply select the temperature band, and then put the filter the time period, and all of those things will be same. Just you have to change this parameter for wind speed. Instead of the wind speed, you will just simply put the temperature data.
Okay.
Okay, so it's very easy. You can easily do it. Just import your image collection for the temperature, and also select the temperature band and other things. All of those things will be same. Okay, so you also try. And if you don't know that, you can send me the code link, then I'll try to fix the problem. No problem. Okay, you try. I also send you this code. Yeah.
Okay.
Okay. Thank you. Okay. Okay. Bye. Have a good day. Okay. Bye.